Concrete bonding is an important part of electrical safety, especially in farm buildings. It ensures that electrical current can flow safely and helps to prevent electrical shocks. In the case of a concrete aisle, bonding is necessary to create a continuous electrical pathway between the metal conduits, junction boxes, and other electrical components. Instead of removing the concrete entirely, consider these options. One approach is using bonding rings to connect metal conduits to the concrete floor. These rings provide a conductive path for electrical current. Another alternative is grounding rods, which can be driven into the ground to provide an alternative path for electrical current. They can be connected to the electrical system through a grounding wire. Conductive epoxy can be applied to the surface of the concrete to create a conductive layer. This layer can then be connected to the electrical system. Steel mesh bonding mats can be placed beneath the concrete surface before it is poured. These mats provide a continuous electrical path between the metal components and the concrete. The most effective solution will depend on the specific circumstances. Consult with a qualified electrician or structural engineer to determine the best approach. The electrical inspector may still require some form of bonding even if using an alternative method. Safety should be the top priority in any electrical installation. If removing the concrete is absolutely necessary, consider these options. Saw cut a section of the concrete, remove it and replace it with new concrete containing bonding mesh or rebar. Apply a thin overlay of concrete with bonding mesh or rebar over the existing concrete. Grind grooves into the existing concrete and insert bonding mesh or rebar that can be connected to the electrical system. It is important to communicate concerns and explore all options with the electrical inspector. Working together, a solution can be found that meets safety requirements while minimizing disruption and costs. The goal is to ensure a continuous, low-impedance ground fault path. Without this, any fault current could energize metal parts, creating a shock hazard. Section 547.9 of the National Electrical Code, or NEC, covers grounding and bonding requirements for agricultural buildings. This section emphasizes the need for equipotential planes to minimize voltage differences in livestock areas. The concrete floor itself, if properly bonded, can serve as part of this equipotential plane. When concrete is poured without proper bonding, several issues can arise. Firstly, the risk of electric shock to animals and humans increases significantly. Stray voltage can create a hazardous environment, leading to health problems and decreased productivity in livestock. Secondly, the absence of bonding can lead to equipment malfunction and premature failure. Electrical equipment relies on a stable ground reference to operate correctly, and without it, surges and voltage fluctuations can damage sensitive components. Thirdly, it can be difficult to pass electrical inspections. Electrical inspectors are responsible for ensuring that installations meet the requirements of the NEC and local codes. An installation without proper bonding is unlikely to be approved. When considering alternative methods to address the lack of concrete bonding, it is crucial to ensure that the chosen method provides an equivalent level of safety and performance. Here's a detailed look at some of the alternatives. Firstly, bonding rings. These are typically made of copper or other conductive materials and are designed to be embedded into the concrete around metal conduits or equipment bases. They provide a convenient point for connecting grounding conductors, creating a localized bonding network. To install bonding rings effectively, core drill holes into the concrete around the conduits or equipment. Insert the bonding rings into the holes and secure them with epoxy or another suitable adhesive. Connect a grounding conductor of appropriate size to each bonding ring and run it back to the main grounding electrode system. Secondly, grounding rods. Driving grounding rods into the earth provides a direct connection to ground. While they are not a substitute for concrete encased electrodes, they can supplement the grounding system and improve overall performance. To install grounding rods, drive them into the ground at strategic locations around the building. The number and spacing of grounding rods will depend on soil conditions and local code requirements. Connect a grounding conductor of appropriate size to each grounding rod and run it back to the main grounding electrode system. Thirdly, conductive epoxy. This material, is designed to create a conductive layer on the surface of the concrete. It can be applied to areas where it is difficult to install traditional bonding methods. To apply conductive epoxy, clean and prepare the concrete surface according to the manufacturer's instructions. Apply the conductive epoxy in a thin, even layer, ensuring that it covers the areas where bonding is required. Connect a grounding conductor of appropriate size to the conductive epoxy layer, following the manufacturer's recommendation. Fourthly, steel mesh bonding mats. These mats consist of a grid of steel wires that are welded together to form a continuous conductive plane. They can be laid on top of the existing concrete and covered with a thin layer of concrete or other suitable material. To install steel mesh bonding mats, clean and prepare the concrete surface. Lay the bonding mats on top of the concrete, ensuring that they are in good contact with the surface. Connect a grounding conductor of appropriate size to the bonding mats and run it back to the main grounding electrode system. When evaluating these alternatives, several factors must be considered. Firstly, conductivity. The chosen method must provide a low impedance path for fault current to flow back to the source. Measure the resistance of the bonding connection to ensure that it meets code requirement. Secondly, durability. The bonding method must be able to withstand the harsh conditions of an agricultural environment, including moisture, chemicals, and physical abuse. Thirdly, code compliance. Ensure that the chosen method meets the requirements of the NEC and local codes. Consult with the electrical inspector to get approval before proceeding with the installation. If removing a section of concrete is considered, it is important to follow proper procedures to minimize disruption and ensure a safe and effective repair. Firstly, saw cut the concrete. Use a concrete saw to cut a section of the concrete around the affected area. Make sure the cuts are clean and straight. Secondly, remove the concrete. Use a jackhammer or other suitable tool to break up and remove the concrete from the saw cut area. Be careful not to damage any underground utilities. Thirdly, install bonding mesh or rebar. Place a layer of bonding mesh or rebar in the excavated area. Make sure the mesh or rebar is properly connected to the existing grounding system. Fourthly, pour new concrete. Pour new concrete into the excavated area, ensuring that it is level with the surrounding surface. Allow the concrete to cure properly before using the area. Applying a thin overlay of concrete with bonding mesh or rebar can be a cost-effective solution, but it is important to properly prepare the existing concrete surface to ensure good adhesion. Firstly, clean the concrete. Use a pressure washer or other suitable method to clean the existing concrete surface. Remove any dirt, debris, or loose material. Secondly, apply a bonding agent. Apply a bonding agent to the concrete surface to improve adhesion between the old and new concrete. Thirdly, install bonding mesh or rebar. Place a layer of bonding mesh or rebar on top of the bonding agent. Make sure the mesh or rebar is properly connected to the existing grounding system. Fourthly, pour new concrete. Pour a thin layer of new concrete over the bonding mesh or rebar, ensuring that it is level with the surrounding surface. Allow the concrete to cure properly before using the area. Grinding grooves into the existing concrete and inserting bonding mesh or rebar can be a less disruptive way to add bonding to the floor, but it requires careful execution to ensure a good electrical connection. Firstly, grind grooves. Use a concrete grinder to cut grooves into the existing concrete surface. The groove should be deep enough to accommodate the bonding mesh or rebar. Secondly, insert bonding mesh or rebar. Insert the bonding mesh or rebar into the grooves. Make sure the mesh or rebar is properly connected to the existing grounding system. Thirdly, fill the grooves. Fill the grooves with epoxy or another suitable material to secure the bonding mesh or rebar in place. Allow the material to cure properly before using the area. In any of these scenarios, it is best practice to involve the electrical inspector early in the process. Discuss concerns and propose solutions to ensure that the final installation will meet code requirements. Document all communication and agreements with the inspector to avoid misunderstandings later on. Regular inspections and maintenance are essential to ensure the long-term effectiveness of the grounding and bonding system. Inspect all grounding connections annually to ensure that they are tight and corrosion-free. Test the resistance of the grounding system periodically to verify that it is within acceptable limits. Repair any damage to the concrete or grounding system promptly to prevent electrical hazard. In agricultural buildings, special attention should be given to protecting electrical equipment from moisture, dust, and chemicals. Use enclosures that are rated for the environment and follow manufacturers' recommendations for installation and maintenance. Implement measures to prevent rodents and other pests from damaging electrical wiring and equipment. Rodents can chew through insulation, creating a shock hazard. Ultimately, the decision on how to proceed with concrete bonding will depend on a variety of factors, including the specific circumstances, budget constraints, and the requirements of the electrical inspector. By carefully considering all of the options and consulting with qualified professionals, it is possible to find a solution that meets the needs of the situation while ensuring the safety of people and animals. Remember that electrical safety is not just a matter of code compliance, it is a matter of life and death. Take the time to do the job right and ensure that the electrical system is properly grounded and bonded to protect everyone who uses the building. The primary goal of equipotential planes is to minimize step and touch potentials. Step potential is the voltage difference between the feet of a person standing near a grounded object. Touch potential is the voltage difference between an object that a person is touching and the point where the person is standing. By creating an equipotential plane, these voltage differences can be minimized, reducing the risk of electric shock. To create an effective equipotential plane, all metal objects within the livestock area must be bonded together. This includes metal stalls, water pipes, feed troughs, and electrical equipment. The bonding conductors must be of sufficient size to carry the maximum fault current that could occur. The equipotential plane must extend throughout the livestock area, including any areas where animals may come into contact with the ground. The concrete floor itself can serve as part of the equipotential plane, but it must be properly bonded to the grounding system. The grounding system must be connected to a grounding electrode system that meets the requirements of the NEC. The grounding electrode system typically consists of one or more grounding rods, plates, or other electrodes that are buried in the earth. The NEC provides detailed requirements for the size and installation of grounding electrodes. In addition to equipotential planes, agricultural buildings must also be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit, preventing electric shock. GFCIs are required in all 125-volt, 15 and 20 amp receptacle outlets that are located in damp or wet locations, such as those found in agricultural buildings. GFCIs should also be used to protect other electrical equipment that is likely to be exposed to moisture, such as pumps and motors. Regular testing of GFCIs is essential to ensure that they are functioning properly. GFCIs should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Surge protection is another important consideration for agricultural buildings. Power surges can damage sensitive electronic equipment, such as computers, controllers, and variable frequency drives. Surge protective devices, or SPDs, are designed to protect equipment from power surges by diverting the excess current to ground. SPD should be installed at the main service entrance and at any sub-panels that serve sensitive electronic equipment. Regular inspection and maintenance of the electrical system is essential to ensure its safety and reliability. All electrical equipment should be inspected annually by a qualified electrician. The inspection should include a visual examination of all wiring, connections, and equipment. Any damaged or worn component should be replaced immediately. The grounding system should be tested to ensure that it is providing a low impedance path to ground. The resistance of the grounding system should be measured using a ground resistance tester. Any deficiencies in the grounding system should be corrected immediately. The electrical system should be protected from overcurrent by fuses or circuit breakers. The fuses or circuit breakers should be properly sized to protect the wiring and equipment. Fuses and circuit breakers should be inspected periodically to ensure that they are in good working order. The electrical system should be properly labeled to identify the circuits and equipment. Labeling helps to prevent accidental contact with energized parts. All electrical panels and equipment should be clearly labeled with the voltage, amperage, and other important information. The electrical system should be protected from physical damage. Wiring should be run in conduit or other protective enclosures. Equipment should be located in areas where it is not likely to be damaged by vehicles or other equipment. The electrical system should be protected from moisture and corrosion. Wiring and equipment should be installed in accordance with the manufacturer's recommendations. Enclosures should be sealed to prevent moisture from entering. The electrical system should be protected from rodents and other pests. Wiring should be run in conduit or other pest-resistant enclosures. Openings and enclosures should be sealed to prevent pests from entering. In addition to these general guidelines, there are a number of specific requirements for electrical installations in agricultural buildings. These requirements are outlined in the NEC and in local codes. It is important to consult these codes to ensure that the electrical system is in compliance. By following these guidelines, the risk of electrical hazards can be minimized and the safety and reliability of the electrical system can be ensured. Always consult with a qualified electrician for any electrical work.